Okay, we're going to look at the last set of numbers called irrational numbers, and they make up, together with the natural and the whole and the rational, they make up something called the real numbers. All together, they make up the real numbers. But the irrational numbers are not rational. What that means is you cannot write them as a fraction of integers. For example, there's no rational number which you can multiply by itself to equal 2. You can get numbers that are pretty darn close. Like I think 1.4 times 1.4 is pretty close to 2, but you can't get one that exactly equals 2. Now, there in the history of mathematics, there were people that didn't believe in rational numbers, but it's been proven that they really exist and they're really pretty important. Okay, so what's an irrational number? A number that can't be written as a fraction. One of them is root 5. You just can't write it as a fraction. All those square root of 10, the square root of 3, the square root of 7, all those surds, you can't write them as ratios. And this special number, the distance around a circle divided by the diameter, which is called pi, that's an irrational number. Now, if you try to write them as a decimal, you can, but their decimals never form a pattern and they never terminate. Like 2.5 is 2.5 or 5 over 2, and it goes 2.5 with 0, 0, 0 or whatever. Irrational numbers, the number just goes on forever in a pattern that doesn't repeat itself. The square root of 3 is just the same. It's 1.73205. If I took all these decimals and I multiplied them together right to the 8, I'd get a number incredibly close to 3, but it wouldn't equal 3. I'd have to keep getting my computer to give me more and more, and I'd never get there. It's an irrational repeating decimal that doesn't repeat, rather. It's a decimal that keeps going on, but it doesn't repeat. Okay, so now we have an exercise. This is the exercise that we're given. Just be careful. Remember, if you can't write it as a ratio, it's not rational. But sometimes they can kind of give you numbers that don't look like fractions. Like, say you have the number 3. You'd say, well, that's not a fraction, but it's not a ratio, but it is a ratio because it can be written as 3 over 1. And you might see this, the square root of 9. You go, oh, that's absurd. That must be irrational, but it's not. If it's a perfect square, the square root of 9 means what do you multiply by itself to equal 9? It's 3. 3 times 3 is 9. So that's a rational number. Don't be fooled. Even the negative of the square root of 9 is negative 3, and that's a rational number. So we have 8 numbers that we have to decide, are they rational or are they irrational? That's the exercise we're going to do. Okay.